right, so we're going to look at, everybody, how to do mole to mole ratios. And so what we're going to do is we're going to look at our chemical equation. So here's our chemical equation for the burning or the combustion of octane, gasoline, right? So what we look at is, if you look at the front of each of my different parts of my equation here, there's numbers out front there. Remember, if we call those coefficients, and that's what we use to balance out our chemical equation, right? So we need 2 of the octane for 25 oxygens, 16 CO2s, and 18 waters to make that balance, okay? But those numbers are also the number of moles that we have, right? So I have 2 moles of C8H18, 25 moles of O2, 16 moles of CO2, and 18 moles of water, okay? So those numbers represent moles. And what we can do is we can use them for a comparison for between the different elements or different compounds in our reaction, okay? So a possible ratio that I could do is between C8H18 and O2. So the ratio is, for every 2 octanes that I have 25 O2s, okay? Or another way we could write that is by writing it as a fraction. So I could do like 2 C8H18s for every 25 O2s, right? Means the same thing, right? And I can flip that up and down as well, okay? Another possible ratio would be C8H18 with carbon dioxide, or C8H18 with H2O. So for every 2 moles that I have of the octane, I have 18 moles of H2O. Now, I didn't go through and write them like this for each of the other ones as well, but you could do the same thing, right? It could be written as the same way, okay? Or another combination I could have is 25 oxygens for every 16 CO2s, or 25 oxygens for every 18 waters, all right? And then the last combination would be 16 CO2s for every 18 H2Os, okay? So those are known as mole ratios, and we can write them like this, or I wrote them all as this, okay? Okay, so those are our different combinations that we could have. And all we're doing is just comparing the numbers out front between 2 of the different parts of the chemical reaction, okay? So let me show you how we'd use this in a problem, okay? So the question's asking us the number of moles of O2 that are required to react with 1.33 moles of C8H18. All right, so we're going to use our mole ratios, but first we're going to write down the starting point here. So 1.33 moles of C8H18. And then what we're going to do is we're going to use one of those mole ratios. We're going to set it up like this, and we're going to set it up in a way that we can cancel out our units and end up with an answer for how many O2 moles we'll have. So if you remember, how we set this up is we want to be able to cancel the units. So if I'm starting with moles of C8H18, I got to have moles of C8H18 on the bottom down here, so they cancel, okay? So I'm relating C8H18 and O2. So right here I have the relationship. Every 2 moles of C8H18, I have 25 moles of water. So for every 2 moles of C8H18 I have 25 moles of O2. All right? So my units cancel. All right? And then when I calculate this, remember, I multiply the top numbers and divide by the bottom number. So 1.33 times 25 divided by 2. So I got got 16.625. If we round to significant figures, 16.6 moles of O2. Okay, so we used our mole ratio from above here to help us solve that problem. Okay, so let's do another one. So the next one, we got CO2, that's what we're trying to figure out, and we're burning, again, the C8H18. Okay, now you see this term excess O2 over here. Really for this problem, that doesn't really matter for us. It just means we have extra O2. But we're not concerned about that because we're concerned about the octane, the C8H18, and the CO2. So I'm starting with 2.5 moles of C8H18. And again, I'm going to use that mole ratio that we've talked about before, all right, between CO2 and C8H18. So right here, for every 2 moles of C8H18 I have 16 moles of CO2. So again, I'm on the bottom, I'm going to put my C8H18, because that's what I started with here, so I can cancel those units, and then I have 16 moles of CO2. All right. That up, I guess it was off the screen there. Okay. So if I do the multiplication, 2.5 times 16 divided by 2, we end up with 20 moles. 20 moles of CO2. Okay, so that's the general process. You can go through and do the rest of the worksheet, but that is how we figured out the mole ratios.